Okay, guys. Good evening, everyone. Welcome to the 12th session of Project J. Okay, I hope you are all doing fine, doing well. So I'm Amirul, and I'm going to be your lecturer for today. So guys, today we're going to do some coding application of AI. So on how we can build a classifier system. But first, before that, you guys need to know what is expert systems, what is classifier, what is forward chaining, and also backward chaining. So let's get started. Okay, so what is expert systems? Expert here refer to the human experts, such as a doctor who is specialized in medical field, an engineer, an architect, a chemist, a physician, and so on. So those are the experts at a certain field. So expert systems are built based on those people. It is designed, the expert system is designed to capture the knowledge of those experts, such as their ability to reasoning, their ability to solve problems, and so on. So our expert systems, which is also an artificial intelligence system, have the ability to keep on absorbing the expert skills, which are the things that I have mentioned just now. So the expert systems absorbs all these expert skills so that they can operate just like the expert itself, even better than the expert itself. So inside expert system, we need to have a certain method to represent the knowledge of those experts. So one way of doing that is by using rule-based to represent the knowledge inside the expert systems. So today, we are going to build a classifier system, which is derived from rule-based expert systems. So it is just a simple program, just to illustrate to you guys how rule-based expert systems works. So our classifier system later on is going to classify something based on the rules or the knowledge stated inside that program. Okay, so our program later on will be named as self-aware.java. Inside the classifier system, inside our program, we are going to give some characteristics to the program, and it will convert those characteristics into a goal. Okay, for example, I tell the program that something has a characteristic of strong. It has stripes, it is orange in color, it has claws, sharp teeth, and also forward-facing eyes. So what the program will do is, the program will see that, oh, these three characteristics, which is a claws, sharp teeth, and forward-facing eyes are present. So it will classify it as carnivore. And then the program will see that, oh, these four characteristics are present. Strong, stripes, orange, and carnivore are present. So the program will classify it as a tiger. So in the end, we will get a tiger as the output. So in order for the program to get the creature, the tiger, it needs to traverse from here on the left side to the goal, which is the tiger. So this is what we call as forward chaining. We chain, for example, these four characteristics together, strong, stripes, orange, and carnivore, chain together, and then the program will interpret it as a tiger. Okay, So when we are programming this classifier system, we need to know just how actually the program chain these characteristics together. So inside the program, we use AND operator. So for example, we give these three characteristics. So the program will do AND operator. It will see that I give clause and sharp teeth and for fancy eyes. So these three characteristics are present. So the program will interpret it as a carnivore. So as you guys know that if we use an operator, all of these characteristics must be present in order for the program to chain it or to interpret it as a carnivore. And it is also the same for tiger. So if we give it strong, stripes, orange, and carnivore, strong and stripes, and orange and carnivore, it will interpret it as a tiger. So this is forward chaining. So right now, we also want our program to have the ability to reasoning. Because just now I said that this classifier program is derived from rule-based expert systems. So rule-based expert systems have the ability, just like the experts, the ability to reasoning. So we want our program to have the ability to reasoning. So this is where backward chaining comes in. Okay, for example, just now the program has classified based on the characteristics given as tiger. So for instance, we want to ask the program, why do you think it is a tiger? How do you reach the conclusion that it is a tiger based on what I gave you just now? So what the program will do is, the program will do a backward chaining. It will backtrack from the conclusion that it has arrived just now and tell you and do a reasoning how it arrived at the conclusion. So if we ask the program, why do you think it is tiger? So the program will respond with, I think it is a tiger because it is strong, it has stripes, it is orange in color, and it is a carnivore. So in the next instance, we want to ask the program, why do you think it is a carnivore? So the program will do another backward chaining. I think it is a carnivore because it has claws, it has sharp teeth, and also it has forward-facing eyes. So as you can see, this is what we call as backward chaining. It will backtrack from the conclusion to the characteristics that was given just now, right? To explain to us how did it arrive at the conclusion. It gives us the reason. So this is the ability to reasoning, to answer the question that was given to it. Okay. So in a nutshell, forward chaining, the program will travel from left to right, from the leaf nodes to the root node. But for backward chaining, the program will go from right to left, from the root node to the leaf nodes. Okay, let's do an exercise to test your understanding. So for example, I tell the program, I give the program that I tell the program something has a characteristic of strong, it has stripes, and it is orange in color only. I only give the program these three characteristics. So do you think the program will classify it as a tiger? So the answer is no. The program won't classify it as a tiger. Why? Because we are missing one characteristics, which is carnivore. So how we can do that? If we want the program to classify as a tiger, we need to give another three characteristics, which are claws, sharp teeth, and forward-facing eyes. So the program will do forward chaining, classify as carnivore, and then based on these 4 characteristics, it will classify as a tiger. Okay, for backward chaining. Let's try another example. If the program arrives at the conclusion that it is a carnivore, then I want to ask the program, why do you think it is a carnivore? So what do you think that the program will do? So the program will do a backward chaining. It will go back. It will give me a reason as how it arrived at the conclusion that something is a carnivore. So the program will say that I think it is a carnivore because it has claws, it has sharp teeth, and it has forward-facing eyes. So those sums up of what we are going to build today, which is self-aware.java, our classifier system. Okay. So next, we are going to have our tutor to demonstrate to us, to show us the program, and they will explain to us how do we actually implement all of this inside the program. So with that, I will end my presentation and I will pass it to the tutor. So thank you.
Alright, so I will continue to demonstrate on how to code the self-aware program. Okay, so here we have public class self-aware. So firstly, we must have a instance variable. So first we have a list of strings of appearance, cheetah, tiger, zebra, horse, fish, whale, and snake, and crocodile. Next we have string of tigers array, cheetahs array, carnivores, zebras, herbivores, swimmer, and insect. And string of specialty animal, question 1, question 2. And lastly, we have a boolean of carnivore status. So first, we have to create a constructor to allow the class to able to create an object. So here we have public self-aware with argument of list string appearance and string animal. So next, we must also have accessor and mutator for appearance, tiger, and cheetah. So for this example, I will only show you only 2 examples of animals. Okay, so next we have public void check specialty. So this method is to give the output what the animal actually is. Depends on what the input that we give to the program. So for example, when the input that we give, when the input that we give met all the conditions. For example, like strong, has lines or stripes, orange, and carnivore status equal to true, which means it is a carnivore. So the program will print or give the answer that the animal is a tiger, and it will update the animal string with tiger. So here is the example for the cheetah. So it has the characteristic of fast, spots, yellow, and also a carnivore. So when all the conditions is true, it will print out that the animal is a cheetah and update that the animal string equal to cheetah. Okay, so next for public boolean check carnivore. So this method is to check whether from the characteristic that we input that it will give the animal is a carnivore or not. So here we have a condition of that to be a carnivore, the characteristic must have forward-facing eyes, claws, and sharp teeth. So if all this condition is true, depends on what we input, so it will update the carnivore status equal to true, which is a carnivore, and return value true. So as if the characteristic that we put is not in the one of this, it will update the carnivore status equals to false and return value false. So next, public void while. So just now we have already know what the animal is, depends on the characteristic. So this method is to want to ask the program, how do you know that the animal is that animal? So here we have, if the animal equals tiger, so we can ask question. We can ask here, why is it a tiger? So we must input, why is it a tiger? So the program will give or print, because it has lines and orange color, is a carnivore and is strong. So next we want to know why that the program say that the tiger is carnivore. So we ask the second question, why is it a carnivore? So that the program will give the output, because it has forward facing eyes, claws, and sharp teeth. And here for the cheetah. So when the animal equals to cheetah, we also ask the same question. Why did you say it is cheetah? Why is it a cheetah? Because, so it will explain the characteristic of the cheetah. Because it has spots, a yellow color, is a carnivore and is fast. And again, we ask, why is it a carnivore? So also same with the tiger, because it has forward facing eyes, claws, and sharp teeth. Alright, so that's all for the method on the self-aware program. So for the main method, I will pass it to the next tutor to explain on how to implement the methods just now. So that's all. Thank you.
Hello everyone. Um, for that, I will in charge to explain to you about the main method of the self-aware Java. So I will start. Okay. There is a public static void main. So because we want to test our program and we want to test the method earlier that we discussed about. So I will start with public static void main. So next, we have the string answer and attribute. So why we have the string answer? Because we want to accept the to store the data in answer and attributes. So next, list string apps equals to new array list. So we have the variable of apps. So we want to store the data in array list. So when user want to key in their data, so it will store in the apps. So we have the scanner as, which is new scanner system in. So we want to read the what user key in after, when we run the Java. So next we have carnivores, tigers, and cheetah. This is you want to remind us that we have the data to classify the carnivores. For example, claw, sharp teeth, forward facing eyes is the data for that is classified as the carnivores. And this tiger is lion, orange, claw, sharp tail, forward facing eye, and strong. Is all of this data, the orange color is the characteristic of the tiger. So as for cheetah is also the characteristic of the cheetah. So next we have the list trained tigers as the array list. So when user want to add um, to store their data, their characteristic. So it will store in the array list in the tiger, cheetah, and carnivores. That's why we have difference here. There is S and there is no S here. Wait, carnivore. So we have the appearance. So before this, you have list tree app. So we want to print the appearance. So we need to do this equation appearance equals to apps. So next we have the software sample equals to new software with two parameters, apps and animals. So the samples, we want to access the method that we do earlier. So we want to access it, and we just need to write like this: software sample equals to new software with parameters apps and animals. So apps is the characteristic, and the animal is for the backward chaining, and it is for forward chaining. So the answer is N, because we want to enter the loop earlier. So we just need we so we want. Hello, can you hear me?
Yes, can.
Yeah, so I will continue. The answer is N. So we want to run the loops. So it will loop until we finish enter the characteristic. So in loops, we have the system out print line. Please enter the characteristic. So it will print to prompt the users, and the attribute equals to s.next. So we want to read the characteristic that user key in into the attributes, and it will add into the array list that we declare at first. That is string attribute, so it will store it into string attributes. So next, system out print line. Are you done? If we want to prompt the users whether they have finished enter their characteristic of the animal. So the answer is the next line is answer is next to read the second key in from users whether they finish or not. And we have the selection. If an answer equals to y, it will break. It means when user finish enter their characteristic, so it will break the loops. So next we have the sample check carnivores. There is appearance. So we want to check the carnivore the appearance by using the method earlier. So if true, it will print the check specialty appearance, which means the all user key in the characteristic, it will print the appearance, and it will sample y because we want to the reasoning. So sample check specialty appearance is just want to determine whether what type of animal based on their characteristic, and the sample y is want to the reasoning based on the animal that they want to know. For example, they want to know why is a tiger, so it will reason and answer the user's question. So I will try run for you to test the software Java. So I will run. So wait, as you can see, please enter the characteristic. So you need to enter the characteristic, the animal that you want to know. For example, strong, and it will print, are you done? So if you done, so you can type Y, or if you want to enter the other characteristic of the animal, it will you can enter N for no. So I want to enter the characteristic, so I will key in N for no. So it will print again because it will in the loop, it will still in the loop because it's still no. So kalau if yes, it will break the loop. So I will enter the characteristic. So no, I want to enter other characteristic, and it will still in the loop. So are you done? No. Orange, and I will still want to enter the characteristic. So still I want to enter the last one for characteristic. Again. So okay. So I done enter my characteristic, and I will key in Y for yes. So it will determine based on the you enter the characteristic before, and it will print what type of animal that certified with the characteristic that you enter. So the animal is a tiger. So it's mean I want the tiger once. So I reasoning why is a tiger. So I don't know why is a tiger. So I will question the program why is a tiger. So it will help you to answer it because it has lines, and orange color is a carnivore and it is strong. So I ask myself, what is the carnivore? Because I don't know what is the carnivore, so I can ask the program. So why is it a carnivore? So it will help you because it has a forward facing eyes, claw, and sharp teeth. That's how. So as you can see, the characteristic that you enter is the forward chaining process. So it's strong lines, forward facing eye, sharp teeth, orange. It will classify as what's the type of animal that certified with the characteristic. So that is a forward chaining process. So for the backward chaining is we ask again the program, why is it a tiger? So it will answer the and try to reason why is it a tiger. So because it has a line and orange color, is a carnivore and it's a strong. And why is it a carnivore? Because it has forward facing eye, claws, and sharp teeth. This is how the backward chaining process. So that's all for the software Java. So before I end the session, I will remind you that the material has uploaded in our website, and um, um, the recorded video, it will uploaded on YouTube in a few days. And don't forget to follow our social medias. That's all for me. Thank you.
Thank you for doing the presentation. Okay, guys, did you guys this session? This was your first session in AI coding. You have another session, AI coding part 2, which I'm not going to spoil the surprise. You're going to get some pretty huge stuff for just let's say programming the board. So yeah, that's that. Did you guys like the session? Did you guys understand what went on? We basically explained about classifiers through expert systems and rule-based expert systems. And as we're STEM kids, we always need a demonstration. So the program that we just demonstrated to you guys was the exact implementation of the graph that we showed you during the lecture inside the Java ID. All right, guys? So you may ask, why the program we showed you count as an AI? Sure, it's a classifier, but why does it count as an AI? Because it has a sense of interpretation. As you guys know, we sometimes, us humans, we understand something without being said. We understand it based on the concepts, based on the things that we have around us, and based on the formation of those, we understand a new thing. We call it interpretation. Okay, so that's what it did. So for instance, let me just share my screen for you guys. I apologize beforehand if I get laggy. So as you guys seen, we had this graph. Okay, we had this tree graph. Basically, in this part, in this very simple example, the program is interpreting that if the characteristics of the creature has claws, sharp teeth, and 4 basic guys, it's going to interpret that it's a carnivore, right? So it's able to basically mimic a sense of intelligence, as we explained to you in the previous sessions. Artificial intelligence aren't really intelligent. They mimic intelligence through functionality, through algorithm design of mathematics, and through smart programming, right, guys? So that's how we were able to create a artificial intelligence classifier without using AI libraries inside Java, but by just using static programming of part 1. Are you guys all clear on today's session? Do you guys have any questions about any part of the program? Anything you want us to discuss? Anything you want us to recap on? Would you guys like me to go through the Java program again, explain it very quickly? Would you like that? If you want to, please type yes for me recapping, no or not. Would you like a recap on the program? Okay, sure. So basically, it's very simple, guys. You're going to be able to do it yourselves using part 1. So, and let me see if... Okay, I need to zoom a bit. Let me make sure for it to be clear. Okay. Okay. One moment, guys. Let me zoom in for you guys so you can see it clearly. Okay, so we have the instance variables as always. You have the class, self-aware. Here are imports. Okay, the array list, the array, the list, and the scanner. Okay. This session's new syntax was lists. Okay, so you're going to use this a lot after you practice with Java, especially in data structure. You're going to use this a lot because it's flexible. You can add stuff to it, delete stuff from it. Very simple, just by adding and removing. Okay, it's very useful. So we have the list of appearance, cheetah and tiger. Ignore this remaining. You can actually try to repeat the pattern we made and try to create examples for zebra, horse, fish, whale, ant, snake, crocodile, and also herbivore, swimmer, and insect. Okay, so these are just for your guys to basically use as an algorithm to add more to the program. For this example, we only have the list of appearance, cheetah, tiger, and the array of tigers, cheetahs, and carnivores. So some people may ask me, as many people even in our university though, and why do we have 2 cheetahs and 2 tigers? Great question. You're going to see it in a moment that why we have that instead of just having one list, okay? So before we get to that, let me just go line by line and explain to you. As you know from your part 1 object-oriented programming class, you know that constructors are our way of creating parameters for objects. So we use these to create objects. So what do parameters do our object need to have? We want it to have the list of appearance. The appearance is what we add to their characteristics, the scanner. You saw our dear tutors adding the parameters from the graph. And then we have the string of animal, which is the name of the animal. Okay, we set them here. Simple. Again, a friendly notice. Why do we have self-aware instead of this keyword? Because it's static. Okay, guys. So just a reminder from part 1. After that, another new thing we have is accessors and mutators, sophisticated name for setters and getters. So before you get confused, it's a pretty simple thing. It's just for good practice, okay? Setters and getters are as they seem. You set a value and you return it, okay? So you set appearance, pass it the list appearance, and you get the appearance. Simple as that. Nothing to get worried about. And sometimes you may want to say, okay, so if it's just a good practice, but it's pretty, I mean, it will take some time to write it down. So why do we even do it? It's pretty good because in sometimes you may need to use setters getters without knowing it beforehand. So a hack that I'm going to show you guys for making your life easier is that all you have to do is right click, source action. You see here, you can add setters and getters, okay? You say generate setters and getters. Here, it's going to bring you the name of the variables you want to have setters and getters. Okay, so something you can use. You can use for constructors, but this is for default constructor. You can also change it, okay? So that's that. Something you can use, something that you're going to use a lot if you want to write programming fast, okay? So we have the setters and getters for appearance, cheetah, and tiger, okay? After that, we have the specialty method. Okay, so now we get inside the real stuff, the specialty, the check carnivore, and Y method. So remember from the graph, we said we have 2 chainings. Forward chaining to answer the question of how, basically getting to the result of the classifying. And we have the backward chaining to basically be able to resemble it, as your lecturer explained it very clearly and with detail, okay? So in the check specialty, we're going to check for the special characteristics of each animal. Before I get to that, let's first get to the carnivore and then to that. Okay. So public Boolean check carnivore with a parameter of list. Okay. So this is what we're going to add to and pass it to. So it's basically the list string A is the list of our inputs, strong, lines, whatever you're going to add. Okay. So I'm going to pass it there. It has a return type of Boolean. Okay. Public Boolean. So it returns a Boolean value. Okay, so you have your conditions. If the list you have contains forward-facing eyes, claws, and sharp teeth, okay, and operator, remember from the graph, and operator. Here, and operator, okay. So that's the imputation of that. So let's get back to the program. You have the AND operator, okay. So basically, it's going to say, okay, so if I have these characteristics. So I'm a carnivore. So you set the value of the carnivore status to true. You set it. Okay. 1 equals sign. After that, you return true. If not, which is your else condition, you set it to false and return false. Now let's get back to the specialty. So we have the public void. Void means it won't return anything. Okay. It's going to just set the values that you want. Check specialty, and again we're going to pass it the list. So we have two conditions, one for tiger, one for cheetah. So just a friendly reminder, if you want to add more examples like for whale, for ant, add it in condition from here, okay? And if you want to add for herbivore, you can add a check herbivore instead of check carnivore, okay? Simple as that. So here we're going to check for specialty of either tiger or cheetah. So because the program starts from the first line, we're going to return first line. So the animal contains strong, yes, it contains lions, correct, and it contains orange, that's true. And it also contains the corner sets of true from here. So the animal is tiger. It's going to print that, same as what you saw in the demonstration. It's going to set the value of the animal string to tiger. So that's how you get the value of tiger. So here, using a method, this method, and this method, you implemented forward chaining. Okay, basically moving from this side of characteristics, the initial inputs that you added in the graph, to the right side, which is the conclusion, which is the hypothesis that the animal that you created is a tiger. Forward chaining. Now we're going to implement the ability for it to be able to answer questions about itself, basically being self-aware of its decisions. What's self-aware? Rule-based expert system using backward chaining. Basically, just a friendly note for you if you ever get confused. We use forward chaining to answer the questions starting with how, and we use backward chaining to answer questions starting with why. Okay, so let's get back to the program again. So using specialty in carnivore, we implement forward chain. Now we want to implement backward chaining. Okay, we use the method why. So it's void again, and this time instead of passing it the list, we're passing it the animal. Okay. So we have this scanner which allows us to take inputs from the user, and we have our two conditions. Okay, so line by line, I'm going to go down. If the animal is a tiger, if the animal string equals tiger, go inside the loop. So our animal is a tiger, so it's going to go inside the condition. We have our first question that you're able to write. So if the question matched why is it a tiger, it's going to print out the reason. Well, because it has lines, an orange color, is carnivore, and is strong. Next up, we're going to ask the second question, which is the carnivore. So why is it the carnivore? Because it has forward-facing eyes, claws, and sharp teeth. This way, you're able to implement the values, okay, the values that you added, and it's going to defend its reason, okay? It's going to be able to defend the view and decisions I make. Same as that, we have it for cheetah. It does the exact same thing, okay? So finally, we get inside our main method, the thing that we're running, okay? So we create two strings, string ans and string attributes. We instantiate, we create a list string of APP to replace appearance, okay? Then we're going to add the scanner for inputs, and then they're going to create 3 arrays. Remember from the first part of my demonstration that I said I'm going to explain to you guys why we have 2 lists for tiger, cheetah, and carnivore for each of them? That's because it's smart programming, okay? You had a session in your part 1, I recall, that you were you understood what space complexity is, what time complexity is, and the smart programmer is a programmer that is efficient. So, as you guys remember, I said that lists to add elements to a list, you have to manually add each element one by one. So you're going to basically implement tiger, you have to add each of these line by line. So it's going to take more space and more time to progress. So the reason that we have 2 is just for smart programming. So we know that we can create the array fixed, okay? When we create an array, it's fixed. So we're going to use that characteristic of array in the good way. So we set these We say that a carnivore has claws, sharp teeth, and forward-facing eyes. A tiger has lines, orange claws, sharp teeth, and forward-facing eyes, and strong. A cheetah has spots, yellow claws, sharp teeth, and forward-facing eyes, and fast. Okay. So for now, forget about cheetah. Just focus on tiger. Okay. In a moment, guys, I'll answer your question in a moment. So after that, we copy, basically we copy every element of the arrays inside the list. So basically transport it from this part to this part, okay? And then we're going to use the list that we created to add a new reference to appearance, okay? After that, we create a new object as an instance of class self-aware. We pass it the app and animal, okay? So some of you may ask me, what if we're going to ask the question from the user? Right, in the initial program, we have the initial value of answer to n. We have this so we can be able to go inside the while loop. Okay, so we set the initial value of answer to n so we can go inside the while loop. Okay. Why? Because the while loop only iterates until the answer is equal to n. So if you want to iterate, you have to set the initial value to n. After that, it input the appearance of the animal. Yes, when you run the program, basically, let me show you the example. When you run the program, you're basically adding characteristics. In a moment, I'll show you how the characteristics are transported to the list, okay? In a moment. So, let me close this. Okay. Yeah, basically the appearance list is the list of all the characteristics that you input. You're going to be able to add the characteristics to the list using the model that I'm explaining right now, okay? So it's going to print down line that, okay, please enter characteristics. Using the scanner, you're going to be able to add attributes, okay? Remember the scanner attribute? Then this is the part that I told you that is going to be important. It's going to add the attribute to the list, okay? So that's how your list has the attributes that you pass to it. After that, it's going to ask you, are you done? If you want to add more examples, you say n for no. If yes, you're going to say yes, and it's going to go inside the condition, and then it's going to break the while loop and come outside. So imagine you added every single characteristic, you're done, you type y, it breaks the loop, it comes out. So this last 4 or 5 lines are pretty, and the only thing that could basically be challenging about this program. Which aren't. I'm going to explain in a simple manner how it's very simple, okay? Remember that I said you pass the list that you created under the name app and appearance. You pass that and it checks whether it's a carnivore or not. So in the first part, because you need to have the order, first you're going to check whether it's a carnivore or not. So you say object dot method dot parameter. Okay, so it's going to give you basically find out whether the animal is a carnivore. Basically, if a sample is a carnivore, okay? If the value of that is true, if true, please outline the carnivore status, okay? So forget about that. This part is the important part, this two. So if you have the check specialty, remember, again, we're going to pass it the list, the appearance list. So it's going to specify what animal it is. So up to now, using this and here, we implemented forward chaining inside our main method. And our last step is to implement backward chaining. So we have sample.y.animal. Okay, so we pass it the animal. And when we run it, this is how it's going to work. So first line that you have is please enter characteristics from the while, correct? You're going to input your values one by one, n for when you're not done, y for when you're done, okay? So here is the value of the characteristic. So was the animal a carnivore? Yes. So it's true. You can use this. As a way to make sure that your program works. Okay. So if I delete this line, nothing's gonna happen. Okay. Nothing's gonna happen. It's going to just jump to what the animal is a type. Same as what our demonstrator showed you. This is for you to basically check when you're programming the code. So it's going to print that this is in the animal is a tiger. From what? From the specialty method. Okay. So now we're done with the forward chaining. We're done with the forward chaining from here. So up to now, the program is finished to this year and now at this line, okay? Line 112. So it's going to ask you, give you basically the ability to ask questions. So you ask, why is the tiger? It's going to answer. And after that, you're going to be able to ask, why is the carnivore? It's going to be able to answer. So that's how you're able to implement the graph inside the static environment of Java. So let me see the questions you guys had. Okay. What is the A in the line 51 for? So I'm not sure if I answered the question before, but basically, as I said, A is the list that you pass. Okay, the list that you pass. Basically, the list of characteristics. Okay, so here is you added appearance. Okay, this is basically a name you can put any name in a parameter. Okay, because you're going to care about the kind of the parameter rather than the name inside the method. Okay, not inside the main method. So that's that. I hope you I answered the question. Yes, thank you, tutors, for answering this question. So any question, guys, about the program or anything you want me to explain again, anything you want me to demonstrate or show you, anything you want, feel more than comfortable to ask, okay? Anything you want me to ask, anything you want me to explain a bit more or show you more. You have 30 minutes of Q&A. Anything you want to ask, feel free to ask. Any question, guys? Anything you want to ask? Anything about the program? Anything about the AI part? Alrighty then. If you have no question, guys, before you leave, and we would appreciate it if you guys give us a comment on how the course is going on the AI part, if you're enjoying it or not, if there's anything you want us to change or improve. And we'll be grateful if you guys give us and describe the course in a few keywords if possible for you guys. Each and every one of you, if possible. Okay, thank you very much. It means a lot to us. Alrighty, so before you guys leave, just give us a comment and then feel free to leave if you have no question left, okay? Thank you so much. Thank you for joining us. Thank you for spending time. We hope that you enjoyed the session. Yes, Daniel, that's our goal. Basically, what I want to teach you guys is that nothing is hard. You may think that AI is hard. You may think that quantum mechanics is hard. Nothing is hard when you have good resources and you have good teachers, or when you have just time to basically explore it on your own pace. You know, nothing is hard. The only thing that is challenging for each new thing is the mindset of it. So right now, you guys have understood the mindset of programming and AI. So that's how you're able to understand it even faster than we anticipated. I'm very proud of you guys. Thank you, guys. Please, your opinions means a lot to us because this course is something that we did for you guys. So we would appreciate if you will see how you guys think about our course, how you feel about it, if you want us to change anything, you want us to add anything. We'll appreciate it if you guys give us a comment before you leave. All right, guys. Thank you for joining us. Thank you for being here. Yes. In the following sessions, we're going to have more examples. So the reason that last session had more introduction theory is because I want you guys to be more familiar with AI. Okay, so basically, I'm going to do either a recording of myself explaining to you guys for AI intro part 1 and post it to YouTube, or if you have time, I'm going to redo the session, give you guys a bit more context on the highlights like symbolic thinking, intelligence, and using that, guaranteed you're going to be smarter, guaranteed, because you're going to have a better understanding of your own intelligence, and thus you're going to be able to solve questions a bit better, much better, if I would say, if I say so myself. Yes, sure. We'll try our best to add more examples for you guys. If you guys have no question, guys, if you are all clear on today's session, and if you have no question even other than the session, feel free to leave. Thank you for joining us, and thanks to our TA, our tutor, and our lecturer for giving us such a wonderful session. We're grateful for all of you, and we would appreciate it if you, before you leave, you will give us a comment on the course and how well it's going, because it means a lot to us. Thank you so much. Have a nice night.